I'm pretty sure most of you know the year Siemens was founded in, right? Some trivia here. When was it founded in? 1847. 1847, a while ago. And basically, it wasn't much more than a startup back then, if you want to put it that way. And it was founded by Werner von Siemens and built up to what it is today. And Next 47 is basically all about bringing this original founding spirit and the ingenuity into modern day times, taking it to the next level, so to say. We're going to be talking about digital manufacturing, agile manufacturing, just some keywords to throw in here. And to take us through the next sessions, I'd like to welcome from Next 47, Vikings Machado. Nice to have you.
Nice to have you, Chris.
Stage is all yours. Brought your fans with you? All right.
Hello, everyone. Thank you for being here, first of all. So, Next 47, that's a pretty new acronym within the Siemens world. So as Chris just mentioned, we are a new Siemens entity. We are a venture firm founded by Siemens. We're a fund of nearly €1 billion based in Palo Alto, California. And basically, why are we actually there? Why was Next 47 created? Basically, because we see a new innovation paradigm. I think this is not something new. Most of you are seeing that. So basically, we're moving from a world where companies like Siemens and some of the others we are seeing there were technology providers to bigger companies. And all of a sudden, what we see here are just small companies popping up, disrupting industries. We've seen that, for example, in retail. Good example, Amazon, Alibaba. We've seen that in the hotel industry. So companies like Siemens are not... Airbnb could be thinking about developing technologies for hotels, but no, they're the new hotels. They fully disrupted an industry. Airbnb is worth more than Hilton, for example. Pretty much happened to Uber. And then you guys may think, so what does it actually have to do with all these things we're seeing here in industrial fair? This is coming closer and closer to our industry. This is coming closer and closer to our business. Good example of that, additive manufacturing. I mean, have a look at the traditional manufacturing processes. You'd design, you'd make a first prototype, you'd prepare the tools, you'd prepare the machines, and then you would take to production. Nowadays, you design something, you can go straight to the production, just shorten up a bunch of cycles. And try to imagine how much disruption is along the way. Another example, artificial intelligence. Try to think about the huge service troops calibrating machines around the world that we as Siemens and also a bunch of our competitors have. Artificial intelligence can from one day of the other simply substitute all of that. So that's why we are there as Next 47. And again, why? Why are we looking at this ecosystem? We see more and more of these companies we're calling the unicorns, which are really top innovative companies, which all of a sudden they become $1 billion private-owned companies, disrupting the world, creating new things, and we want to be part of that. So Next 47 is a new part of the Siemens innovation environment. So we still have the divisions, the regions, corporate technology, looking forward, close to you customers, but we are also looking at the external environment and trying to bring closer to us the startups that will be part of this disruption. We are investing in these companies, we are partnering with them, and we really want to be there when this disruption happens. So we want Siemens to last long, really, really last long. So Next 47, that's where the name comes from. So the key reason, however, why we're here today is not to talk about Next 47, but to give some room to some of the startups we have recently invested in and partnered with, where we believe that are bringing significant innovation to the market and where we see potential disruption coming from. So Mark Forged, the first one to present here today, additive manufacturing space. Outstanding company. We'll be showing some great technology here. Identify 3D, which helps on the digital thread, making decentralized production really something serious. Let me call it this way. And Tulip, who is supporting manufacturing to be just better. So, thank you. And I'd just like to open rooms for our entrepreneurs. Andrew.
Hey everybody, my name is Andrew DeJofoy. I'm the VP of Application Engineering at Mark Forged. And that's a really fancy way of saying I'm a printer salesman. So as Wickings mentioned, we are additive manufacturing, which most people commonly know as 3D printing. And what we're going to talk to you today about is accelerating the process of bringing a new product to market by what we call accelerating hardware. And many of you may be familiar with this, the Tesla Roadster. This was the first car that Elon Musk and team brought to market. And if you look at a car, it's a very complex, complicated piece of machinery. And that's evidenced by all the different parts that you need to make. And you can clearly see that's not actually a Tesla. But essentially, there are lots of different parts that go into a car. And each one of those goes through a long line of iteration, sometimes dozens or even hundreds of iterations to get to a final usable end state. So you see here, this is an example of what that looks like. And each one of those parts has to go to who we call Frank. Frank the machinist is the guy who typically would take that part and say, OK, it's going in my backlog. Maybe I'll get to it in 6 weeks. And every single one of those iterations you want to do has to go through Frank. And what we're trying to do is figure out how we can speed that up. Now, once you've got that part, the prototype ready to go, now you actually have to mass produce this and create molds and things like that. Doing injection molding is not really anything new. Humans have been doing it for over 7,000 years. The process has been refined, but it hasn't changed all that much. And finally here, you have to actually set up your manufacturing line to be able to produce that product at a large scale. So that's why it took the Tesla 5 years to have a Roadster. In 2008, when they launched it, that was after 5 years of product innovation and developing all the different necessary parts to bring that to market. And the really crazy thing is that that's about the same amount of time it took for Ford to bring the Model T to market. So 100 years have gone by, and almost nothing has changed in terms of how long it takes to bring a really complex product to market. So this is kind of where we come in. We wanted to be able to come up with a very easy way that you can effectively choose a part, choose the material you want to print it in, and print that on any printer around the world seamlessly from one place. And that's what we've built with MarkForge. So we support a full range of materials because different products may be made of several different materials, but any individual part, you want to be able to choose the best material possible for that. So we support a full range of materials from plastics to composites to metals, and we'll talk a little bit about each of those briefly. So this slide got messed up. This is supposed to be a great timeline of our company history here, but it looks like the slides got a little messed up, so we'll just jump ahead. But essentially, what we've developed when it comes to metal 3D printing, which is all the buzz right now, and you can go over and check out, we've got some sample parts over here you can play around with. But essentially, we've pioneered this process called atomic diffusion additive manufacturing. If you're familiar with MIM, it's similar in that we can produce parts that pass MIM standard by printing 3D printed sort of green parts that can then go into a standard sintering oven or our own end-to-end proprietary sintering system. And that's really our thesis here, is that hardware should be fast. We want to accelerate the process and try to take it down from 5 years down to 1 or 2 if possible. So we're going to go through and talk a little bit about some applications of where we've been able to do this in prototyping, actually creating end-use parts, as well as product assembly. So here, this is actually a cutaway of an impeller, a turbine for a turbocharger. Basically, we can produce the impeller here you see on the right side. What this does is takes exhaust from the engine and uses it to spin a turbine, which turns a shaft connected to an impeller and adds more oxygen to the engine, increasing its efficiency. So this is a perfect example of where we can help prototype that part, because as you can see, this is a very complex part that if you were going to do traditional machining techniques, that might take you several weeks, if not maybe months to iterate on, and you need a 5-axis CNC machine to be able to produce that. Now, we can 3D print that part. Our total print system to print that part end-to-end will cost about $125,000. But the total time to produce that individual part is going to be around a day and a half, and a cost of about $950. So what would typically cost you thousands of dollars to iterate on every single time, and weeks if not months, we can turn around and actually help you iterate on that prototype part in just a couple of days at a fraction of the cost. But what we really want to talk most about now today is end-use parts. So we have a few case studies here. I'm not going to go into too much detail on them because they're all available on our website at markforged.com/applications. So you can download all the details on this there. But a few highlights. This is an example of, well, and the background text got changed to, the background got changed and the text didn't. But the really key point here is that this is a CENTERLINE Engineered Solutions is a customer of Markforged. They essentially use our 3D printers to print industrial press brakes that they can use to then produce parts for their customers. Most cases, doing this is prohibitively expensive, but by being able to spin up and produce a new press brake tooling fixture, they can essentially do this for customers in a way that they never could before. I'm going to jump ahead here to the end. Again, there should be text here. Not sure why there isn't, but so this is an example of a part. It's a lathe bar puller. I won't go into the details of what that is for people who don't know, but essentially this is a part that would typically take $10,000 to $30,000, and we can produce that for under $10 per one. These case studies would be great if I actually had the data on them. Sorry about that. So I'll jump ahead to some of the ones that hopefully came out a little bit better. So Stanley Black & Decker is a customer of ours. They have a $1.5 billion division that focuses specifically on heavy industry applications. So these are very low production tools with long lifespans. They need to be extremely durable. They have to be high value. These are tools that are going into equipment that's thrown around all day that's really taking a beating. And so as an example, this is a post driver. Now, if you look at this post driver, there's essentially a hydraulic actuator up there that you can see is a pretty complex piece of machinery. And when these break down, they're really hard to replace, partly because they have several different components that need to be iterated on every time. And what you can see here is we were able to design that for additive manufacturing and 3D print that as one single part, which allows us to derive tremendous ROI, iterate those faster, and get them spun out much quicker. The ROI on this was tremendous. So we actually have an example of this over to my right here, to your left. And essentially, we're able to produce this part at about a 42% cost reduction and 69% faster than they typically make them for a production run model. As a profile grinder, another example of a part where a very complex thing that doesn't need to be replaced very often. So it's prohibitively expensive to have to create a new one of these every time they need to. We were actually able to consult with them on breaking this into 3 different pieces that could either be taken off the shelf or 3D printed using our metal printers so that they can just print the part that they need that's hard to create and use off-the-shelf stuff to speed up the time to production. And you can see the ROI there, 35% cost reduction, 48% faster. And again, these are all on our website if you want more details. And I've got a couple people from my team here from Markforged that we can take questions at the end as well. One of the things that's especially useful about what we do at Markforged is you can buy one printer if all you need to do is make a couple prototypes, or you can buy 100 printers if you need a much larger production footprint. And we make it very easy to scale up and down based on your needs because of that. Lastly, we'll talk about assembly. So this is, again, going to how do we take all those different parts of the car and pull them together. And as Elon Musk said, what really matters is being able to scale up production volume as quickly as possible. Last month, Tesla was supposed to produce 1,500 Model 3s. They only made 260. And a lot of that comes down to their manufacturing line and their inability to assemble and put these cars together as quickly as they need to. So this, this is another example of this. And an assembly line, now that you've actually done prototypes, you've put together your end-use parts, you actually have to build a manufacturing line that can produce all these. And we actually have a lot of applications there that can help as well. Again, another case study with no text, but the idea here is that Dixon has been a long-time customer of ours, and they use our 3D printers to produce gripper jaws that can be used to pick up and move the different valves from place to place. These are things that need to make sure they're not going to damage the actual part itself. So we have non-marring materials that they can use to pick up and move those parts, as well as steel grippers that we can use to, let's see if this will play, essentially pick up and go into a valve and spread out to pick it up. But it has the hardness needed to pick that up and handle a threaded part without damaging itself. Another example here. This is Haddington. This is a robot that was built by Haddington in Las Vegas. This is a startup that makes modular, configurable robotics with onboard supercomputers running open source code. The really cool thing about this is they printed every part of this robot using our 3D printers. And so that's a real example of they're able to completely build their own assembly line and their robots using our 3D printers. And again, we can do this for things like lapping fixtures, custom lathe tooling, non-marring CMM fixtures. And this is another example on this is a major automotive manufacturer. Essentially, they had production line stoppages constantly. They had a car chassis that was crashing down on the locator tabs, which were made out of machined aluminum that kept breaking. An engineer printed a mark-forged fiberglass part replacement, took it home, beat on it with a hammer to prove how hard it was, and then he replaced a single cell on the line, and that cell stopped breaking down. Now every cell has mark-forged parts, and they were able to improve their car production time to about a new car every 12.3 seconds. And the engineer who introduced that solution was promoted as a result. So that's a story we love to talk about. And again, because we offer the full range of materials, we allow you the freedom to choose the right material for the right job. And here's a breakdown of when you want to use different ones for different use cases. But essentially, we are trying to sort of span the entire production life cycle, and that's really how we're trying to sort of crunch that down from 2.5 years down to a much reduced process that could even be as short as less than a year or 1 to 2 years. And that's it. So thank you. And we are over at Hall 6, K30. We have actual printers there to demo. So feel free to stop by with our Mark 3D reseller partners. They're over there demoing that. And we'll be over here taking questions if you have any. Thanks.